Are you a Home Assistant user that's sick and tired of having to replace a SD card every 6 to 12 months? Or do you just want more speed out of your Raspberry Pi and Home Assistant? Well, on today's episode, we'll show you how to configure your Raspberry Pi, run Home Assistant off of a solid state drive to get a much larger speed boost and increased reliability of your system. Ever since I've been using Home Assistant, I've had an issue where about every 12 months, I start having problems with my Home Assistant instance just randomly stopping. I go downstairs, I look at the Pi, and the network lights are on, everything looks fine, but it just crashes, it stops working. Well, this is because the SD card that I use ends up wearing out. SD cards are not meant to run operating systems off of. They have a limited numbers of reads and writes, and after those get exceeded, you start having reliability issues. So I did some research and found this great guide on how to install Home Assistant on a solid state drive. Full credit goes to forum user JPSY, Jorg Wagner, or Wagner, I'm not sure how that's pronounced. He has written an excellent guide that has been updated numerous times on how to run Home Assistant on a solid state drive using a Raspberry Pi. Now, this is something that's only been introduced on the Pi 4s. They have a special EEPROM, a bit of flashable memory where you can set to boot from a USB device. This is a very cheap and easy way to upgrade your Home Assistant instance into getting some of those more closer to desktop speeds that you would if you had a dedicated server. Now, I have an Intel NUC running my Linux server in the basement. I'm actually running Proxmox on it, so it's running a bunch of virtual machines, and I do have a virtual instance of Home Assistant. I like having the redundancy of having a separate piece of hardware running my Home Assistant instance in case for some reason the virtual machine crashes or the virtual host crashes and I'm not able to access it. I'm still able to see my Home Assistant devices. I'm still able to control my lights and other things. I still like to run mine on a separate Raspberry Pi 4. Now, last year I upgraded my Pi 4 from a 1 gig to a 4 gig version, and at that time I swapped out the SD card. Well, after about 6 months, I've been having problems again. I figured this is a perfect opportunity to go ahead and switch over to a solid state drive and a great opportunity to make a video about it. So the overall steps that we're going to be going through, again, I've got a link to this guide if you want to just skip the rest of the video and you just prefer to read through it. View his excellent guide, it has all the details. But in this video, I'm filling in some of the missing components that he just assumes that you know if you're a long-time Raspberry Pi user or Linux user. So if you're looking for detailed steps, that's what this video is for. If you just want to skip through to the end, feel free to click on the link in the description and go through his guide. All right, so let's look at what's needed for this. All right, so before we can start on the software portion on how to set this Raspberry Pi up with a solid state drive, let's go over what hardware is required. I'll be using a 4 gigabyte Raspberry Pi 4B. There is, I think, variants that go from 1 all the way up to 8 gigabytes now, but the one I'm using is 4 gigs, and I just have the standard off-the-shelf Raspberry Pi case. I'm using the Raspberry Pi 4 official power adapter. One of the notes on this guide is that it's important to use one with a high enough power output so that you can power both the Raspberry Pi and the solid state drive adapter. This is important because if you start to run low on the amount of power available, it will cause the solid state drive to be very flaky, and the drive adapter we're using does not have an external power supply on it. Next up is the solid state to USB 3.0 adapter. This is the one from StarTech. It's linked in the description below. It's the one that's recommended by the original author of the guide. He states that it's important because this has a particular chipset that works with the Raspberry Pi 4 bootloader. So make sure you get an adapter that is compatible, not just one that you find in a drawer somewhere. Then I'm using a 240 gig solid state drive. This is just a generic solid state drive that I got from Micro Center. I happen to have laying around. Really, the size doesn't matter all that much as long as it's big enough to support your database, which does get quite large, and the files and components in your Home Assistant instance. So what you'll need is a standard micro SD card. This one's 32 gigs, but you can use anything probably 8 gigs and bigger. This is only to load the initial Raspberry Pi OS on board, so that way we can update the boot EEPROM on the Raspberry Pi 4. You can then recycle this and use this for another project later on, but it's recommended to go ahead and keep one of these around just in case you run into problems booting off the SSD later on. This can be used to recover the files off your solid state drive. And optionally, if you happen to have a micro HDMI adapter, a monitor, keyboard available, you can use that to set up the Raspberry Pi, but I'm going to show you a method that you can use just using SSH, which I think is a lot easier. and it requires less items. All right, so now that we know what hardware, let's get started by flashing both the solid state drive and the SD card. So we're gonna go ahead and flash Raspberry Pi OS on the SD card and then make one change to a file to enable SSH. So remote into the Pi and flash that EEPROM. Let's go ahead and start by taking the SD card and putting it in a USB adapter, and then we'll get it flashed. All right, so before we can flash Raspberry Pi OS on the drive, we need to get it downloaded. So you can just go there by either clicking the link in the description or in the lower third here, or go to raspberrypi.org/software. So they have a nice built-in imager that will download the current version of Raspberry Pi and flash it to your SD card automatically. So we'll go ahead and download that version for Windows. Obviously, if you're on Mac OS or Ubuntu, you can do that through the links listed here. But once that downloads, we'll go ahead and flash Raspberry Pi OS and then make that modification to the SD card. All right, so that is downloaded. We'll go ahead and run the imager and go ahead and install it. I'm sure I had an older version already on my... All right, so let's run it. And so then we want to choose the OS that we want to use here. Now we'll go ahead and do the 32-bit here because it really doesn't matter. We're just using this to boot from. This is the desktop version, which we don't really need the desktop version because we're going to be accessing this via SSH. So if you're more comfortable and you're going to be doing this with HDMI, you can go ahead and select the desktop version so you'll get the GUI interface. If you just want to do the command line, we can go ahead and grab the light version with no desktop environment and go from there. So I'm going to go ahead and do the light so it'll be faster. All right, once you've selected the proper OS, we need to make sure we are flashing to the correct card. So in this case, I actually have a 128 gigabyte drive in my machine along with a 500 gig SSD. So I want to make sure I don't overwrite those because that'd be very bad. So I'm going to select this as the SD card device I have connected to my reader. Once you do those two things, click write, make sure you have the correct one, and hit yes. Now this is going to go ahead and write. It's going to split the drive up appropriately so the Raspberry Pi read it, and we'll go ahead and skip through this. All right, now that the SD card has been flashed successfully, we can click continue. It tells you to go ahead and remove it from the reader, but don't do that just quite yet. We want to make a quick modification to the boot drive on the SD card. So let's go ahead and open up Windows Explorer. And let's navigate to the boot drive. There you'll see all of the information on the boot partition of the drive. This is the only one that's readable by Windows natively. So what we need to do now is create a blank file called SSH. So to do that, we'll go ahead and open up Notepad. Nope, you can use Notepad or Notepad++, either one. So I opened up Notepad++, create a new document, go to File, Save As, navigate to that boot partition, and then select all types. This will allow you to create a file without a extension, so not .text or .bat, whatever it is. So you'll be able to create just the blank file. So you can call the file name SSH and then hit save. And you can confirm that by going in to your boot partition and finding the file in here. And there it is. So the file has been created, and it should be a file type of file because it has no extension on there in Windows. So what that's going to do is when your Raspberry Pi boots up and it sees that SSH file, it will enable SSH. Then we have to go into the Raspberry Pi configuration on that first boot and change it to permanently allow SSH. If you boot this Raspberry Pi up one time and then restart it again, it'll remove that SSH file from the system and you won't be able to access it via SSH. Now let's go ahead and move on to getting the solid state drive flashed. Let's go ahead and get the installer ready for the SSD, the solid state drive. So to flash the solid state drive, I'd recommend downloading this application Etcher. It's free for Windows and it seems to be the best kind of gold standard for flashing both SDs and SSDs. So I already have it installed, but you can click the link in the description or go to the shorter URL here at the bottom and download this. And then once you get it downloaded and installed, we'll go ahead and run it. So now that we have the application to flash the SSD, we need the software to download for that SSD. So we're going to pop over here to the Home Assistant releases and grab the latest release 5 version, which at the time of this recording is build 10 or 5.10. So we're going to scroll down here to the assets portion of the page and we're going to look for HAS OS Raspberry Pi 4 RPI4-64 -- the version number. So again,
We're going to be running the 64-bit version because that's the version recommended. It used to be 32-bit was recommended on the Raspberry Pi 4, but now they recommend the 64-bit version. So we want to download this .img file here. So we'll go and click on it and then save the file. All right, now that the file has been downloaded, because we'd installed the Raspberry Pi OS installer, it automatically associated that file type with it, which you could use that to flash the SSD, but I find Etcher's a little more reliable, so we'll go ahead and use it. So I'm going to select the image, which in my case will be my downloads folder. So again, HasOS RPI 4-64.version number. Click open. And then we're going to select the drive, where you can flash the SSD you need to attach it to the adapter. It's just a friction connection here, so you'll just press it in, and once it's held in there, it's held pretty securely, so you won't even need to place this in an enclosure or anything. I'll actually just attach this to the wall where I place my Pi down in the basement, and then zip tie it to the pegboard I have there. That way it stays up there and secure. All right, so now go ahead and attach the USB 3 port to your computer. Obviously, attach this to a 3.0 port to make this flash go faster. It should work with the 2.0 port, but I'd recommend a 3.0 port if you have one available on the PC you're going to do the flashing on. All right, now that we have a solid-state drive attached to the USB adapter and that's plugged in and successfully loaded into Windows, now we can go ahead and select the drive. And we want to select this SSD 240 gig. Again, make sure it's the correct one before you flash it because you don't want to overwrite on one of your existing drives. Click continue and then flash. Now it will pop up on Windows and ask to run as administrator, which is fine. And we will go ahead and let this run. Shouldn't take too long because it's not a giant image and we're using the 3.0 bus, so it should be pretty quick. So it says about 10 minutes. So we'll go ahead and skip this and then finish up the drive here in a minute. All right, now the solid state drive is finished being flashed with Home Assistant. So we can go ahead and disconnect it and we'll hold on to the solid state drive for the later step. So now let's jump into connecting to the Raspberry Pi with Raspberry Pi OS and getting it configured to flash the EEPROM. Now I noticed when I had the USB port plugged into one of my hubs, I was getting an error in my device manager. Well, that's because there wasn't enough power being applied to the solid state drive. So if you plug the solid state drive adapter into your PC and it doesn't show up in Windows or Linux or Mac, make sure it's connected directly to the computer. I had to break out one of my USB-C to A adapters and plug it in straight into one of the ports of my laptop. Then it had enough power to go ahead and bring it up in Windows. So again, like we said before, you need to make sure you have enough power to both run the device and the adapter. So just be aware of that. If you do run into problems, make sure it's connected directly to the computer on a USB 3.0 port so it has enough power. All right, now that you have the SD card flash with Raspberry Pi OS, go ahead and plug it into your Raspberry Pi, and then we'll power it up. And once it comes up and it boots up all the way, we'll be able to SSH into the Pi itself and start making changes to flash the EEPROM. One thing I've noted as well is make sure that if you're going to be connecting Raspberry Pi and you want to be able to SSH into it, make sure you're connected over Ethernet. If you do use your Raspberry Pi with Home Assistant over Wi-Fi, we can configure that all later, but for right now, make sure you're using Ethernet. It will simplify the process a bunch. All right, so after about 10 minutes, the Raspberry Pi should finish loading up the operating system and be ready to be SSH'd into. Now, I had assumed that it would continue using the same IP address that I had before when it was just running Home Assistant, but it looks like it pulled a different one, probably because the operating system changed. So make sure you use your router or whatever gives out DHCP leases on your network and use it to find the proper IP address of the Raspberry Pi. In this case, it was .128 on my network. So I won't go over how to find the IP address using your router. Just Google that. That should be pretty simple. Once you have that one, you'll need to use an SSH application like PuTTY. I like to use one called Termis because it's kind of cross-platform. It's the same interface on iOS, Android, and Windows. It's a free download. You can find links below. Once the Pi boots up, we can SSH into it, and then we'll be able to start the next step. All right, now that the Pi is booted up and we know its IP address, one of the first things you want to do is make sure to ping it so you know you got the correct IP address. So in this case, mine is 192.168.1.128. Then we'll flip over to your SSH application of choice. Again, I'm using Terminus. And you want to give it a name, put in the IP address, And then the username and password is just the default, which is the username is Pi, the password is Raspberry. Once we do that, we'll connect in. The first time you connect, you'll get a warning about the keys. Just go ahead and accept that. Now we are logged in to the new Pi. Again, this is just the Raspberry Pi OS running on the Pi itself. So the first thing we need to do is go ahead and enable SSH for good. So we want to run sudo raspi -config. That'll bring up the Raspberry Pi software configuration tool. Go down to the interface options, which is option 3, SSH, and enable SSH. That's it. Now, if we have to reboot the Pi, we can get back into it via SSH since we don't have a monitor connected. All right, so we'll go ahead and exit that. And the first thing we're going to do is we're going to go ahead and create a firmware update file. All right, so let's go ahead and create a new file. So sudo nano. So we can go to the etc folder, default, and rpi-eeprom-update. Enter, or it'll edit the file that's already there. So what we want to do is we want to change this firmware release status from critical to stable. So go ahead and remove the word critical and change it to stable. Then Control X, select yes to save the buffer, and enter to write the file. Sudo apt update, enter. Now this is going to go ahead and update the Pi, and then we'll do a full upgrade after this. All right, so now we'll run sudo apt full upgrade. And yes. So we want to select no because we don't want to overwrite the file that we just modified at the beginning. So we can hit enter. All right, now we'll go ahead and do a reboot. Sudo reboot. And it's of course going to kick us out of our SSH session. So what we can do to monitor to make sure that when the Pi comes back up again is you can just run that same ping command -t, and that will continue to run until you escape. So we'll just let this run until we ping the device again. Then we'll go back in. We'll resume the SSH session. So now we're able to ping the Pi. So we'll go ahead and reconnect our SSH session. And we're back in. So now we want to run sudo rpi-eeprom-update. And it looks like our bootloader is in January 2021, so that's good. It just needs to be after December 11th of 2020, so it looks like we're up to date. Now we want to configure the Raspberry Pi to boot from the SSD as opposed to the SD card. So we're going to go back into the Raspberry Pi configuration. And then go down to the advanced options, which is option 6. And then go to the bootloader version. And we will want to do E1, which is the latest. Now it's going to ask here, do you want to reset the ROM to default? So you want to say, no. We want to use the latest one. So hit no here. All right, not set to defaults, okay? So then under the advanced options, let's go ahead and go back down to advanced options. Go down to boot order, A6, and allow USB boot. Okay, so the USB device is now the default boot device. So just like in Windows, now if you plug it in a bootable flash drive, it's going to attempt to boot from that now instead of just using the onboard SD card. So now we go down to the finish option. All right, so now that we're out of the Raspberry Pi config, we can run a sudo shutdown -H. That'll halt the system and shut it down in approximately 1 minute. So now you want to wait until the Raspberry Pi, all the LEDs on the front of the Pi go off, so then you know it's shut down and safe to remove it, and then move on to the next step. Now, once everything's plugged in and powered up, you can go to that same IP address, :8123, to find the startup window for Home Assistant. Now, you can use the DNS entry of Home Assistant. So go to your web browser, type in Home Assistant :8123. I can't on mine because I have more than one Home Assistant running on my network. And of course, the first one booting will get that DNS name. So if you have trouble navigating to the Home Assistant :8123, then go ahead and put in the IP address that we used in the previous step. So as you can see here, it's going to give you this nice screen to let you know, hey, you've got everything's connected, everything's configured. We've booted off the SSD, but now it's going to go ahead and unpack and set up Home Assistant. It says it'll take up to 20 minutes. It shouldn't take that long, especially with the high-speed solid-state drive. But this is a time you just have to wait until it finishes with the setup. All right, now the Home Assistant instance has started up. Now, Jorg puts in his guide very specifically, don't jump straight to the restore from a snapshot, because there's some incompatibility issues here and you don't want to have to do this all over again. So go ahead and set up your Home Assistant as just a test system. You don't have to use your current username and password. We're just going to set up the base Home Assistant and then install the Google Drive backup plugin. So once we've done that, we'll hit create account. Again, this is not required at the moment because we are not going to actually use this instance. We're going to restore it. All right, now that we have a functional version. All right, now that the Raspberry Pi is functional with a solid state drive, let's go ahead and get our old instance restored onto this one. So to do that, we'll need to use this great add-on by Stephen Beechin. This is an add-on for what used to be called HAS.io, but now Home Assistant, to both backup and restore from Google Drive. He says here, all you have to do is just add the repository to your supervisor. So we'll go to Supervisor, Add-on Store, and then click the three dots, go to Repositories, and we're going to add the repository here. So we'll go into his, grab this link, and then paste it here to Add Repository. Hit Add, and it's going to add it in to our list of add-ons. So it'll be here at the bottom, so we can click Google Assistant Drive Backup and install it. Should take just a minute. All right, once it's installed, we'll go ahead and start it, and then open the web GUI. So you'll have to authenticate with Google Drive, which I've already done on my other instance, but we'll go ahead and do this anyway. All right, once I've entered my Google information, I'm going to go ahead and allow it to access these items, and we'll copy this for safekeeping, but then hit Send Credentials, and it's going to go ahead and push that over to the system. So in my instance, it didn't work. So I've already copied it to my clipboard and go back and I'm going to paste it here in this box and hit save. All right. And so since I am restoring this from an existing one, I want to use the existing backup folder. So I'm going to say use this folder. It's going to find all of the ones in here. And so as you see here, now I can see all of my current snapshots, and I keep 4 of them in Google Drive, which consumes about 7 gigs, not too much. So right here, I took this one, the snapshot, right before I got started here. So to restore this one to my new Home Assistant instance, I need to go to Actions and Upload. So this is actually going to upload this to Home Assistant. So you have an option, you can delete the existing snapshot, which of course we don't want to do, download it to the computer you're currently on, or upload this to Home Assistant. So we're going to select that option. It says, hey, you want to make sure to upload the snapshot. Now it's going to place this into Home Assistant as one of its snapshots. So then when it's finished, we can restore to that snapshot. So this will take a few minutes, depending on the speed of your internet connection. And you'll see up here, it tells you what progress it is downloading it. All right, now the snapshot's been uploaded to Home Assistant. Now it shows backed up. So if I were to refresh this page, it's now showing it backed up. So it's on the actual drive. So now we can flip over to Supervisor, Snapshots, and right here, we see the snapshot ready to go. So we'll click on that snapshot, and we want to go ahead and restore everything. Now, obviously, it's helpful that I had already updated myself to the latest version. Don't need all of these, but I could probably get rid of a few of them, but I'm going to go ahead and restore everything so I don't forget something. Now this could take a while because these do have to unpack and upload. So it's best just to leave this screen open and then wait until you can refresh the page and have it come back up in your instance. So in my case, I'm going to have a bunch of error messages because I don't have some of my USB devices connected right now, but be able to see pretty quickly if this worked. All right, after waiting about 20 minutes and taking care of a couple of other items, my Home Assistant instance did show up after a couple of refreshes. Now I need to log into it. So this is a restored image of my original instance, but on a different IP address. So I'll go ahead and log into the instance, make sure everything looks good. Then I will jump in to my router and change the IP address to the IP address of the old Home Assistant instance. So that way things like my MQTT servers and stuff all work again. Then I'm going to shut it down and take it back downstairs and make sure it's ready to go. So let's go ahead and log in. And we'll go ahead and jump into Lovelace interface. Of course, I'm accessing it directly by its IP address. I typically access mine either through Nabokasa or through my outside duck DNS, but I can't do that right now because it's pointing to the wrong IP address. So you can either point your instance to the new IP address, or in my case, change the Home Assistant instance to the old IP address. All right, so I have SSH'd into my Raspberry Pi. I've gone into my Unify network and changed the IP address to match the old one. Again, this may not apply to you. I'm gonna go ahead and restart the Home Assistant host by issuing the HAHO reboot command, and this should allow it to restart and then come back up with the proper IP address. All right, now after applying the new IP address and rebooting, my Lovelace interface is coming up. Everything seems to be there. The interface looks like I expect it to, so everything's done. Now all I have to do is take it back downstairs, plug it into the USB port on the UPS and Z-Stick, and we're off and running. So I'm gonna go ahead and shut it down because I've got to move it downstairs. But everything's complete as far as Home Assistant is concerned.
All right, so there you go. Now you have a fully functional Home Assistant instance running on a solid-state drive on a Raspberry Pi 4. Hopefully this will be a noticeable improvement for you going forward with your databases not corrupting like mine always seem to do, with you not having to deal with SD cards that you have to replace periodically, and hopefully just the system runs much faster. I noticed that the boot up is much quicker now that's on a solid state drive, and that an initialization sequence was much quicker. So I definitely am seeing some speed improvements, and I'll report back in the comments how it feels over the next few days. Hope you found this video helpful. If you did, please make sure to give it a thumbs up. And if you haven't already, subscribe to the channel. Trying to develop a community here, so feel free to ask questions if you run into issues along the way. As soon as I can, I'll try to respond to you. I've been blown away with all the comments so far on my last few videos. There's been a lot of questions on there and a lot of positive comments. So if you did find this useful, please make sure to subscribe to the channel for more content. I've got a lot of videos in the pipeline. I just have to finish editing them. It's difficult with a full-time job and kids and a family. But if you have any suggestions for videos going forward, please make sure you leave them in the comments below, or feel free to reach out on any of my social media accounts. I try to be active on there. I'm starting to get used to using Twitter, second Twitter and second Instagram account. So feel free to reach out on those platforms, or like I said, comment below. And if you're interested into when I randomly release videos, to ring the bell, and that will notify you of any new videos that I release. Thank you again. I hope you're all staying safe out there with COVID, and I will see you on the next video. Thanks a lot.